Okay, we have an integral. It involves an infinity, so we're definitely gonna have to use some limits. I'm doing the integral from 10 to infinity of 9 over x minus 8 dx. So these aren't too bad if you just can do some simple limits and if you can carry your limit notation. So the first thing I want to do is integrate. What I get is 9 ln absolute value x minus 8. I guess you could do some u sub there if you wanted to, but it's not super necessary. And I'm going to evaluate it. I'm going to have my lower bound be 10. And then since I have this infinity up here, what I need to do is put a b there and then use limit notation. So I'm going to write the limit as b goes to infinity. Because we've talked about this a fair bit, you can't do arithmetic on infinity. So anytime we got infinities, we got to do these limits. So what do we wind up getting? I'm going to then write equals limit as b goes to infinity of, I get 9 ln absolute value of b minus 8, and then minus 9 ln absolute value 10 minus 8. And then what I do from here is you could simplify this part over on the right, 9 ln absolute value 10 minus 8, but we can just look at this right here. You should know that I'm going to use bad notation here, that the ln of infinity is infinity. We don't want to, like, that's not a good equation to write because really we should be writing limits, but I'm writing that now so that you can recognize that, well, when I plug this in, I get infinity minus 8. Well, that's still going to be an infinitely large number. So this limit right here, it goes to infinity. So what I have is an infinitely large number minus something that is a number. But since I get infinity there, I just write equals diverges. Or I would accept if you wrote infinity as well. So yeah, that's this one. We just get that this piece diverges, and then the whole integral diverges.